equals, let's do x squared plus y squared. And I'm going to sort of draw things. I mean, this is a paraboloid. We have drawn it before. And every cross section is a circle. So it's going to look sort of like this. And it's going to be circular. Every cross section is a circle. All right, so that's going to be our paraboloid. And then we're going to intersect it with a plane. Let's say z equals 4x. So that plane would follow the line. This is, by the way, this is my x, y, z. So it's going to basically be copies of the line y equals 4x, which is rather steep. So for any y, you're going to get a copy of y equals 4x. And that's going to give you a plane that is going to intersect. In fact, I'll continue a little bit further. That is going to intersect this paraboloid, and I do have a picture, don't worry. And that's going to form an intersection that will look sort of like a circle. In this part, so here we're going to look at the graph. So this right here is the paraboloid, and this down here is going to be your x-axis, y, and z. So the plane, remember, if you see it cross-sectionally in the xz plane, it's just going to be the line y equals 4x. Of course, the slope is not that accurate in this case because I have scaled it. And then below that, y equals, z equals x, z equals 4x plane is going to be the paraboloid x squared, z equals x squared plus y squared. So when you look at that intersection, the wedge that you're forming, I didn't mean to rotate it like that, I meant to rotate it in this direction, is going to have a cross section that is going to be a circle, and you're going to have that the z coordinate, and I rotate it a little bit in this direction, the z coordinate is going from the bottom, which happens to be the paraboloid, to the plane. In this case, z equals 4x. I have here the intersection, the paraboloid, and the 4x. If you have access to Mathematica, this would be the code that you would use to plot it. And then you see that now I have to integrate over what I call a shadow, which would be if you were to look strictly from above, the region underneath this circle. That's what you want to integrate over. That's going to be your region R. So I'm going to move on back to the tablet. I'm going to find that region where we want to integrate over. All right, so back to the tablet. To the tablet. So as I said, on the computer, we saw that we're going from the bottom to the paraboloid up to the plane. So now we want to find out what is the region that I need to integrate over. So what's going to happen is that curve, so notice that here there was a circle on the intersection. I gotta find the equation of that circle. And how do I do that? Well, that is circle was the intersection between the plane 4x and the paraboloid. So if you set them equal to each other, well, the color changed there, but that's okay. You will notice that if you subtract 4 on both sides and add some certain number on both sides, what do you get? If you add a half of this and then you square it, you know what I'm doing. I'm completing the square. You write this equation as x minus 2 squared plus y squared equals 4. That is going to be, so if you were to prolong this for every z, you basically have a cylinder that goes down here to the x y plane, and that cylinder, grabbing this circle, this exact same circle for every value of z, what that tells us is you have a circle of radius 2, because this is 4, it's going to be 2 squared, centered at 2 comma 0 here. And so the radius 2 is going to give you a circle here. And that is going to be the region R over which you're going to be integrating. So what is the region going to look like? Well, remember that you could solve here for y, and the top part of the circle is going to be, if you subtract this 1 on both sides, you get 4 minus x minus 2 squared. And then if you go ahead and take the square root, the top part would be the positive square root, and the bottom part would be the negative square root. Negative square root. So that if you write it in the order dx and then, dy and then dx, dz was already fixed. dy dx, why do I pick that order? Because if I'm going to integrate with respect to y, I have to solve everything with respect to x. So in this case, I already have it solved instead of in terms of x. Otherwise, I would have to solve this equation again. So I already have it. In fact, we're going to change the order just to be more thorough. And that seems to be causing trouble in class. So I'm going to go ahead and change the order of this integration as well, just to show you how it's done. All right, so now in this case, I'm going to go from negative square root. Ooh, I didn't give myself any room, did I? I'm going to leave that as a parenthesis. I failed at my planning. I want to move it, but yeah, let's just move it. Let me move this integral, and then we'll write it properly. That's the only problem with these integrals. Some of them take a lot of space to write. Let's give ourselves the room necessary. So negative square root of 4 minus x minus 2 squared. Yeah, I needed a lot of space, huh? And then to square root of 4 minus x minus 2 squared. And now, where are my intervals for the x now? Well, I'm starting at 0 because I have a circle centered at 2 with radius 2, so I get all the way to 0 and all the way to 4. So from 0 to 4. And that right there gives me my integral, the volume. So somebody asked in the previous video or the one before on double integrals, wouldn't it be easier just to do it in this case with double integrals, and for the area just do single integrals? And the answer is yes. However, if you wanted to find, for example, the mass of this wedge that we cut out, and you had a density function, if you integrate this, instead of integrating just the differential of volume here, you integrate rho, which is the density times the differential of volume, you'll be computing a mass. So it really does depend what you're trying to do, but the technique, or what is important, is setting up the integral, and it doesn't matter what you're integrating the differential of volume against. That's why I'm not putting a specific function, because that is not really the intention here. In fact, I'm not even evaluating the integrals, I'm just setting them up. If you're in my class, you know that for the exam, you will just set up the integrals. We're not going to be computing them for this exam. So let's change the order of integration for this one. So let's say that suddenly we're going to decide, for whatever reason, well, the first integral is just it's going to be numbers only. So let's give ourselves some room here. And let's change the order and say that we're going to leave the z alone. But now we're going to change the x and the y. So if I change the x and the y, and I write x and x. So if I'm going to change the order, now if I'm going to go first integrate with respect to x, then I'm going to grab horizontal lines, and I need then values of x. This x and this x. Well, they're going to be obtained from this formula by solving for x. And that's going to give me my
solving for x in terms of y. That's going to give me my endpoint there. So let's go ahead and solve there. So go ahead and solve this equation now. Instead of for y, I'm going to solve for x. So I'm going to have x minus 2. I'm going to do the same thing I did before. So 4 minus y squared. And I'm going to take plus minus the square root on both sides. Okay. So I just subtracted this guy, took square root, plus minus. So I'm going to add 2 on both sides, and I get 2 plus minus the square root of 4 minus y squared. So this side of this half of the of the of the circle is going to correspond to x equals to 2 plus the square root of 4 minus y squared. And the other side, you can imagine, is going to correspond to minus. So x equals to minus square root of 4 minus y squared. So those are my endpoints for the x's. I'll put them in green because then, I don't know, so it looks ugly. Sure. 2 minus the square root of 4 minus y squared. And this is going to be going to 2 plus the square root of 4 minus y squared. And so now I need to go in the y coordinate. I gotta go from, in this case, I'm gonna go from negative 2. How do you find that point? Well, you're centered at 0 for the y coordinate. You're going a radius of 2. So negative 2 to positive 2. That just comes from the equation that we're using and knowing that that's a circle. So from negative 2 to 2. That gives us the integral in the other order. So we could also change the orders with respect to z, but let me see how I'm doing with the length of the video, because as far as I can tell, I already have like 13 minutes, and that's probably good enough for this one. So I hope this helps, and I'll see you in the next one.